Hi, my name is Chen Lihan. I'm going to talk about the final protection. It's about the L'Aquila earthquake. These are the content. First is introduction. I will talk about the earthquake background. Then where strong motion station located. Third is observe strong ground motion records. Then do comparison with ground motion predicted equation. At the end is conclusion. First is introduction. A motion magnitude 6.25 earthquake occurred in 2009. Its epicenter in the Abruzzo region. Its central Italy close to the city of L'Aquila. The yellow star is the main shock. Green star is two strongest aftershocks, and the white box indicates the surface projection of the fault planes, and triangle indicate the RAN strong motion stations. RAN is National Acceleration Network in Italy. The Abruzzo sequence, the two strongest occurred on April 7, and motion magnitude 5.6 were located to the southeast of L'Aquila. And on April 9, the motion magnitude 5.4 was located to the north L'Aquila. There is a clear migration of aftershock to the southeast and to the northwest. A month after the main event, the record contains more than 100 significant aftershock. Their motion magnitude is between 3 and 5, and 1,000 even of lower magnitude. The focal mechanism determined for the aftershock were dominantly normal faulting. Next is strong motion stations. The triangle is 58 centimeter station belonging to the Italy strong motion network were triggered by the main shocks. And square, the broadband seismometer of the INGV network provided 112 non-saturated recording. One of the very broadband stations operated by INGV, AQU, located in the center of L'Aquila, was also equipped with the accelerometer that recorded the main shocks. The locations of the strong motion station closest to epicenter, together with the surface projection of the rupture faults. Only two of 8 stations, AQF and AQP, did not record the main shocks during April 6 night. AQF and AQP records aftershocks start from April 7. The metal box containing the instrument was rusted, so the main shock time history of AQM cannot be considered reliable. Next is observe strong ground motion records. The acceleration, velocity, and displacement trade the main shocks for some of the station. AQG, AQK, AQA, AQV, closest to the fault rupture. The largest peak of 0.6 AG is in the AQV. In east-west direction. The effect of size response can be observed in AQK record, which show the highest low-frequency content, indicating a strong resonance peak as 0.6 Hz, justify the large value of PGD. Around the 12 cm, and AQA records show the higher frequency. And others show the small value of PGD have been found at other stations around 8 cm for AGQ, AGV, and 6 cm for AQA. This figure shows the aftershock on April 7. In following aftershock, the PGA of AQV is quite comparable with those other stations in AQG, AQK, and AQM. It's reasonable to assume the strong acceleration 0.63 G in the AQV during the main shocks is due to high frequency pulse generated by a source effect. Next is comparison with ground motion prediction equation. Horizontal peaks, acceleration, and velocity from processing data of L'Aquila earthquake have been compared with some ground motion prediction equation GMPE developed on the basis of both strong and weak motion data. SP96, AB7, BM7, MAL8, ATA9. And these are the main features of the summarized in this table. The largest horizontal peak around acceleration recorded for the main shocks by the 50H strong motion station RAN. RAN plus INGV is blue circle, and by the 112 INGV a broadband station is triangle 1. The recording values are compared with the GMP adopting epicentral distance as reference measure. In this appropriate empirical conversion rules have been adopted to ensure consistency among different GMPE in terms of distance definition, magnitude, scale, and selection of horizontal component of ground motion. The largest horizontal PGA and PGV value of ground motion recording are plotted as a function of force distance and compared with the value of empirical regression predicted by IT9, ML8, BM7, AB7, and SP96 and their confidence limits. The MAL8 is this dark line, predicted quite well the peak acceleration observed in the L'Aquila earthquake. At distance over 100 km, because their GMPE was produced by using Italian data from the Central Apennines, recorded as local and regional distance well beyond 100 km. Next, at the end is conclusions. L'Aquila earthquake is the third strongest earthquake recorded in Italy since 1972, and after these two earthquakes. The earthquake caused severe loss and damage in epicentral area. The earthquake produced very high acceleration at all stations close to the fault, reaching up to 0.63 G at station AQV, with very short duration and high frequency content of the recordings. The collaboration between empirical predictive relationship and observed PGA show that the empirical prediction underestimates the observed value closely the epicenter overestimate those the background directivity direction northwest sides. That's all my presentation, and thanks for listening.